McDonald's, it'll be fine. Yeah, as long as I hit it in the next few years, it's fine. Okay, determine if the sequence is arithmetic. Now, arithmetic basically means, does it follow a linear pattern? Does it have a specific increase or decrease that it consistently does? And if it is, it wants us to find some formulas that could describe it, etc. So we look at that 28 and we say, does it have a linear pattern? Is there a specific increase or decrease that happens each time? And we can say, yeah, each jump is down 10. So it is in fact arithmetic because it is decreasing by the same amount each time. So we can say yes. Now, as far as the formula goes, if it follows a linear pattern, it should have a linear looking formula. We don't use y and x generally with sequences. We use a sub n and n. So instead of y, I'm going to put a sub n equals. And instead of x, I'm going to put an n. But I still need the same things. I need a slope and I need a y-intercept. Now, we've already talked about the slope. The slope is down 10 each time. So negative 10 n. Now, the thing I need to figure out is the y-intercept. Now, the y-intercept is tricky because generally with a sequence, you're like, well, the first term is negative 2, so negative 2 is your y-intercept. But that's not true because we're not looking for a first term. Think about y-intercepts. Where do you find a y-intercept on a graph? You don't find it on the first term. You don't find it on x is 1. You find it on x is 0. So if the first term is negative 2, the question is, where would it have been back at the y-intercept? So you actually need to backtrack to figure out where it would have been for what we would maybe call the 0 term. Okay, so if we're at negative 32, negative 22, negative 12, negative 2, going backward another 10 would put me at positive 8. That is my y-intercept. Okay, so if you're going to be using the term slope and y-intercept when you're doing an arithmetic sequence, don't forget that little aspect. Now, if you were to plug any number into this formula, you could get the correct term. So let's try it just to make sure we're right. Let's get the third term. The third term is negative 22. So I should be able to plug in a 3 here and get negative 22. Negative 10 times 3 is negative 30, plus 8 would be negative 22. So you can kind of check that and make sure you did it right. If you didn't, then you know you need to change a number. Recursive formulas are easier. Recursive just means give me a formula that allows me to get the next number. So what do I have to do to that negative 32 to get the next number? I have to subtract 10. So basically what you can think of is to get the new number, you need to take the old number, or the one before it, and subtract 10. That's kind of what you're thinking. Now, we wouldn't see it with words. We would see it with symbols. So the new term would just be a sub n. The old term, you describe that by saying a sub n minus 1, meaning the one before it, minus 10. So if you're going to use the appropriate notation, you're going to see symbols like that. But that's basically what you're saying. How do I get the next one? Well, I have to subtract 10. So old one minus 10 will give me the new one. Okay, 52nd term, be pretty easy. We already have an equation that we can use. Now, you could just go through the pattern over and over and over again until you got to 52, but that would take a long time. So instead, we can use our explicit formula and just say negative 10 times the 52nd term plus 8. Negative 520 plus 8. Negative 512. Okay, same pattern on, or same idea on 29, not the same pattern. You look to see if it's consistent. And I see it looks like it's down 200 here. It's a little bit harder to tell on the first ones, but 28 minus 200 would in fact get you negative 172. So we've got a consistent pattern of down 200. That means it will be arithmetic. We're going down the same amount each time. It also means that we can find the formula. Explicit formula is going to be the slope, which is negative 200 n. And then the y-intercept, again, is not the first term. It would be what we kind of call the 0 term. So you have to think, what's in front of the first term? If we could go backward on the sequence, what would we see on the other side? And we would have seen 228, because 228 minus 200 would give me 28. So that 0 term, that y-intercept, y-intercept, if you will, is 228. Recursive formula, same idea as before. How do we get the new term? Well, we take the old term and we subtract 200. That'll get me the new term. So you could use that to get the next term in the sequence after negative 572, and then the next one, and then the next one. So recursive is only good to find the next one. Explicit can find any one. So 52nd term, I'm going to use that explicit formula. Now, negative 200 times 52, negative what, 10,400 plus 228, negative 10,172. Anybody done that? Yeah? We good? Okay, I want to do incorrect mental math up here.